Welcome to today's Explainer. We're taking math right off the chalkboard and turning it into a real-world toolkit. Today, we're going to master a concept that honestly feels a bit like a magic trick once you know how to use it. We're talking about the least common multiple, or as you probably know it, the LCM. So let's dive right into this with a real-life puzzle. Imagine your friend Anna has this beautifully chaotic schedule. She's got a dance class every second day and a painting class every third day. If you've got two schedules running at different intervals like this, how do you find the exact day they finally sync up? I mean, sure, you could guess or you could count on your fingers, but there's actually a precise mathematical tool designed for this exact headache. To solve puzzles like this without just randomly guessing, we're going to follow this exact roadmap today. First, multiples and factors explained. Then, what is the LCM? Next up, 3 methods to find LCM. Followed by real-world LCM applications, and finally, some awesome LCM math tricks and rules. All right, Section 1, Multiples and Factors Explained. Let's just start with the foundational building blocks we need before we can figure out that overlapping schedule. Think of a multiple simply as the result of repeated addition. If you take a base number and you multiply it by counting numbers, 1, 2, 3, and so on, you get multiples. So the crucial point here is that multiples are really just the results of your basic multiplication tables. For example, the multiples of 5 are 5, 10, 15, 20, 25, and they literally just keep going on forever. It's really just step counting by your base number. Now, I know it's super easy to confuse multiples with factors, but they actually do completely opposite jobs. Multiples go up endlessly, kind of like a staircase. They're what you get by multiplying. Factors, on the other hand, well, they're the numbers that perfectly break a given number down into pieces without leaving any remainder. So for the number 16, its multiples go up, 16, 32, 48, but its factors break it down into 8, 4, 2, and 1. Moving on to Section 2, what is the LCM? Now that we know what a multiple is, let's meet the absolute star of this explainer. What exactly is the least common multiple? You're often going to see LCM paired with HCF, which stands for highest common factor. When you compare the two, just remember that their definitions are literally right there in their names. LCM is all about looking at two endless lists of multiples and finding the absolute smallest shared meeting point between them. HCF, though, is about looking at the factors that divide two numbers and finding the absolute largest dividing piece they happen to share. For our toolkit today, we want the lowest possible overlap going forward, which means we are looking for the LCM. Now, you might actually be wondering right now, wait a second, isn't any number multiplied by 0 just 0? Doesn't that make 0 a multiple of literally everything? Well, yeah, it does. But think about it. If we included 0, the lowest common multiple for every single math problem in the universe would always just be 0. And while that's really not very helpful for figuring out our schedules, so in math, we just always ignore 0 when we're finding the LCM. Section 3, 3 methods to find LCM. Let's look at 3 practical ways to actually calculate it, starting with what I think is the most intuitive method. The first tool in our kit is the listing method, and it's exactly what it sounds like. You just simply write out the multiples for each number in a row until you spot the very first number that pops up in both lists. Take a look at the multiples of 3 and 4. As we count up, 3, 6, 9, 12, and then 4, 8, 12, bam! 12 is the very first number that appears in both rows. It is the absolute smallest shared multiple. This method is incredibly visual and honestly great for smaller numbers. But for giant numbers? Yeah, listing out multiples would literally take all day. And that's exactly where we use the prime factorization method. Prime numbers, if you remember, are those special numbers that can only be divided by 1 and themselves, like 2, 3, 5, and 7. By breaking our large numbers down into these prime building blocks, we can construct the perfect LCM formula. First, we identify any prime factors that overlap between our numbers. Next, we take only one single copy of that overlap. Finally, we multiply it by whatever leftover prime factors remain. We do it this way to avoid useless duplicates that would make our final number way too good. Let's actually see that in action. Using that exact prime factorization method, let's say we want the LCM of some massive numbers, like 105 and 120. We definitely don't want to list hundreds of multiples. Instead, 105 breaks down to 3 times 5 times 7. 120 breaks down to 2 times 2 times 2 times 3 times 5. Notice they both share a 3 and a 5. So we only take one copy of that overlapping 3 and 5, we multiply it by the remaining 2's and the 7, and we instantly find the answer is a whopping 840. See? No massive tables required. Our third tool is the common division method. This is an incredibly fast way to solve for multiple numbers all at once. You just line your numbers up, separate them by commas, and start dividing them by small prime numbers, starting with 2, then 3, and so on. If a number can't be perfectly divided, you just bring it down to the next row exactly as is. You just keep dividing until your entire bottom row is nothing but ones. Then, you simply multiply all those prime numbers you used on the outside together, and boom, you have your LCM.
Which brings us to Section 4, Real-World LCM Applications. Okay, so we've built our toolkit. We know exactly what the LCM is, and we've got 3 ways to find it. So let's put it to work on some actual everyday headaches.
Imagine you're decorating for a party and you're buying flowers, but they come in completely mismatched bundle sizes. Let's say Anna needs to buy daisies, which are only sold in bunches of 6, and lilies, which are only sold in bunches of 15, but she wants exactly the same amount of each flower for her vases. How do you know the exact minimum number of flowers to buy so absolutely nothing goes to waste?
Well, you probably guessed it. We find the lowest common multiple by simply listing the multiples of 6 and 15, or maybe using that division method we just talked about. We immediately find that their LCM is 30. That means she needs to buy exactly 30 of each flower. So that's 5 bunches of daisies and 2 bunches of lilies. Zero waste, perfect symmetry, and the problem is solved instantly.
So the really crucial point here is that the LCM isn't just some boring math drill designed to test your patience. It's actually the specific tool you use for everyday logistics. It's exactly what you use for syncing up schedules, perfectly matching quantities in bulk buying, like say hot dogs and hot dog buns, and it's the exact tool you use to find a common denominator when you're adding or subtracting fractions with different bottom numbers in your DIY projects.
Section 5, LCM Math Tricks and Rules. Right before we finish up, let's look at some rapid-fire shortcuts, because let's be honest, the absolute best part of math is finding the loopholes.
So let's look at a few shortcuts that let you skip the heavy math entirely. For instance, prime numbers only have 2 factors, 1 and themselves. Because of this, if you ever want the LCM of 2 prime numbers like 5 and 7, you don't need to list anything at all. Just multiply them together to get 35. Also, if you're looking for the LCM of 2 numbers, and one is a perfect factor of the other, like 6 and 24, the larger number, 24, is automatically your LCM. Pretty cool, right?
So, bringing it all back to our opening puzzle about Anna's chaotic class schedule, remember, dance is every 2 days. Painting is every 3 days. Well, 2 and 3 are both prime numbers. So using that shortcut we just learned, we simply multiply them together. 2 times 3 is 6, which proves, without a shadow of a doubt, that the classes will perfectly overlap on day 6.
And just like that, you now have the complete toolkit to find the hidden meeting points in numbers. We've unlocked complex schedules, eliminated waste in bulk shopping, and totally smoothed out fraction math. The least common multiple is officially yours to wield. Which leaves us with just one question for you. What everyday puzzle will you solve next using the LCM? Keep exploring, keep solving, and I'll catch you in the next explainer.